Hey guys, welcome back. It is week 3 of online instruction, so hopefully things are getting a little easier for you guys, and hopefully you're kind of um, catching on and getting the hang of how everything works. Once again, if you're having any trouble with any of my stuff, definitely let me know. But please do me a favor, and if I put up an information video, watch it before you ask a question that's answered explicitly in those videos. So let's get into chapter 14, which is human remains. Skip past the objective slides, you don't need those. So when we talk about human remains, one of the first things a lot of people think of is anthropology, right? Or forensic anthropology. So forensic anthropology is a type of applied anthropology that specializes in the changes and variations in the human skeleton for the purpose of legal inquiry. So this is looking at a skeleton or looking at human remains and trying to determine how did this person die? Who was this person? Okay, so if you've ever watched the show Bones, she was a anthropologist, a forensic anthropologist, right? Because she used that knowledge and applied it to the forensic sides of things. So this chapter is going to be very in line with what you might see on the show Bones, which if you haven't watched is a great show. All right, so a forensic anthropologist may provide basic information on skeletonized or badly decomposed remains. So, from a whole bone or part of a bone, scientists can determine an age range, the sex, race, height, and potential cause of death, disease, or anomaly. So, for example, there's a ton of data out there about the length of bones and how the length of certain bones corresponds to the height of the individual. So all you have to do, for example, if you were to find a femur, would be to measure the length of the femur and kind of plug that into a formula, and you can figure out the approximate height of the person. There's also definite differences in the skeleton between sex and race. Obviously, if you think of a male pelvis versus a female pelvis, there's going to be very distinct differences because the female pelvis has to be wider in order to accommodate birth, right? Male pelvis does not, so typically has a much smaller opening. Osteology is another part of this, and specifically the study of bones. So there are 206 bones in an adult human. In children, there are more because you have smaller bones that fuse together. And these provide structure and rigidity. They protect your soft tissues and your organs. They give your muscles and tendons a place to attach. Also, within your bones, you have marrow that helps produce blood cells, and they serve as a storage area for minerals like calcium, right? And they can also help detoxify the body by removing heavy metals and other foreign elements from the blood. All right, and here is the formula, or here are the formulas I was referring to. So for a male, okay, it is going to be the length of the femur times 0.2 or 2.23 plus 69.08, and that'll give you the height of a man. So working backwards, you can figure out the length of your femur, right? And here's the formula for tibia, humerus, and radius, and then here are the ones for female. So you can see the formulas are slightly different. So we do need to know the sex before we attempt to plug this in, but you can still plug them in. And for example, if you get a female who is 6'5", that is probably less likely, so you might want to plug it into the other formula. All right, and I apologize, my son just woke up from his nap, and so him and the dog are now joining me in recording. So if you hear any toddler noises, that's him. um, so age determination, the most accurate estimations are made from the teeth, and then also looking at the growth plates. So your growth plates are where your bones literally grow. And as you're growing, you're going to have growth plates, and as you reach maturity, those growth plates kind of disappear. There's also the pubic symphysis, which is the little gap in the pelvis, and then cranial sutures. So when you're young, you have actual holes, essentially, and gaps in your skull. And as your skull grows, they fuse together, and eventually you have one full, complete skull. But if you've ever heard, you know, to be careful with the baby's head because they have a soft spot, that's why they literally have a spot with no bone covering it. And that allows the bones of the skull to kind of move and shift a little bit as the head passes through the vaginal canal for childbirth. So investigators always use a range because of the variation in people and how they age. Not everyone ages as well as other people. And an investigator does not want to eliminate any possibilities for identification. So age determination using these cranial sutures. Okay, so the sagittal suture is completely closed in a male at about 26 years old and a female at about 29 years old. The sagittal suture is completely open. The male is less than 32. The female would be less than 35. And the complete closures of all three sutures, male is over 35, female is over 50. All right, in long bones, the diaphysis, or the shaft, makes up most of the bone's length. The epiphysis are found at the ends of the bones. Those are going to be the growth plates. They're a good place to look for changes in estimating age. All people are different, though, and they grow at different rates, but there are similarities that allow for generalizations in estimating age, but you're never going to look at these and estimate this person was between 21 and 23. You're looking at a much wider range. So stage 1, there would be no epiphysis, so the growth plate has not formed yet. Stage 2, non-union. The epiphysis and the bone are separate. Stage 3, partial union. The epiphysis is attached, but a line is visible. And stage 4 is complete union. The epiphysis is attached and a line is not visible. So here is a clavicle in stages 1 through 4. Okay, you can see no growth plate. Yeah, it's exciting, buddy. Here you can see it's detached. Here you can see the line. And here you can see it's fused. And here is using the medial clavicle examples of what those ages would be. So non-union would be 21 or younger. It's a wide range, right? Non-union with separate epiphysis would be 16 to 21. That's probably the closest little age range there, except for 17, 20, pretty close too. So you can see that once we get past 21, really, this doesn't help a whole lot. Gender differences in bones. So here you can see those two examples of the pelvis that I was talking about. Male obviously has a much narrower pelvis, because it doesn't have to pass a child through there. Female tends to be much wider. So the female has a wider pubic body than the male. So that is the top, okay? And then the female has a wider subpubic concavity or subpubic angle. So if you look at the angle here, okay, these are bones of the pelvis. You can see the angle right here is much wider than the angle right here, which is a little less than 90 degrees. All right, and the last thing on the female or the pelvis is that most females have a ventral arch or a ventral arc. Okay, and you can see that here. So if we're looking at some examples, okay, you should be able to determine which ones are male and which ones are female. Obviously, these are fragments, but just looking at the angles alone, right, this is more than likely male. This one right here is more than likely a male. This one right here is probably a male, and this one here is probably a male. If I had to look at these, I would say the females are down the middle here. All right, gender differences. The rib cage and shoulders of males are generally wider, thanks bud, and larger than those of females. In addition, about 1 person in 20 has an extra rib, and it's more common in males than in females. In males, the index finger is sometimes shorter than the third finger. In females, the index finger is sometimes longer than the third finger. This is not used often as an indicator of gender because there's a lot of exceptions. So according to the above rule, is this a male or a female? Well, the correct answer is you should not be able to determine it because it's not used. It's just kind of a thing that has been noticed over the years. Race is difficult to determine for most skeletal remains, especially since pure races are becoming uncommon. There's a lot of people with mixed ancestry. And experienced forensic anthropologists can generally place skulls into one of three groups. So there's Caucasoid, those are going to be European, Middle Eastern, and Indian descent. Negroid, which are African, Aborigine, and Melanesian descent. And then Mongoloid, which would be Asian, Native American, and Polynesian descent. So race characteristics, Caucasoids have long, narrow nasal apertures, a triangular palate, oval orbits, which are your eye sockets, narrow zygomatic arches, those are your cheekbones, and then narrow mandibles, which is your jawbone. Negroids have a wider nasal aperture, a rectangular palate, they have more square orbits, more pronounced zygomatic arches or cheekbones, and then the long bones are longer and have less curvature, and they tend to be more dense. And last but not least, Mongoloids have a more rounded nasal aperture, a parabolic palate, rounded orbits, zygomatic arches that are wider, and then more pointed mandibles. So to show you examples of these, here you can see the more oval-shaped orbits. You can see a very narrow mandible here. You can see how thin the zygomatic arches are as compared to these two. The orbit shape here would be the more square shape. Here is the rounded shape. Looking at these, you can make the estimation that this would be the more Caucasoid, this would be Mongoloid, this one would be Negroid. All right, so odontology is the study of teeth, and teeth can be used to help determine the identity of someone after death. So things that are found in your dental records like fillings or crowns or spaces between teeth or presence of dental work, okay? All of this can help to make a positive identification. So teeth are often used for body identification because they are very hard and they don't decompose, and they are unique to the individual. So x-rays are one of the most commonly used to do dental identifications. And here you can see some examples. So if you saw this and you saw this, you could probably estimate these may be the same two people, right? Because we have a lot of the same features. You can see the very distinct dental work that has been done. So facial restoration is the combination of art and forensics. So this is looking at a skull and using what are called erasers or depth markers in order to mark the approximate depth of the tissue. And based on those markers, they actually can sculpt what they believe that person looked like. Nowadays, they can also use computer modeling to do this, but it is a very specialized field. And if you're interested in it, I would definitely look into it because there's not a lot of people who do this. All right, so steps in facial reconstruction. So with a skull, first thing, they establish the age, sex, and race. They plot landmarks for tissue thickness. They plot origin and insertion points for muscles and certain facial landmarks. They mount the eyes, and then mount the muscles, and then they add the fatty tissue and the features, right? So like the eyelids, the nose, the parotid gland, which is in your throat, the ears, and then they cover all the layers with the skin. And then they add little details. So here's a case study on facial reconstruction. John List killed his entire family, moved to a new town, and assumed a new identity. 17 years later, Frank Bender reconstructed what he believed List would look like. It was shown on America's Most Wanted, and he was turned in by viewers almost immediately, looking very much like the reconstruction. All right, last but not least is the Body Farm. So the Body Farm is the nickname for a 2.5-acre research facility in Tennessee developed in the 1980s by Bill Bass. And that is where they place bodies to observe and study decomposition. We're going to be watching a good amount of video on that this week, so you'll be able to get into that. All right, and that is it for this week. I hope you have a good week. I hope you enjoy the content I put together for you, and have a wonderful day.